Oops.
Hi, good morning.
Hi.
Good morning, everyone.
So, right, and we start first with, we have three speakers from Nextracker, and we start first with Antonio Sendin, who's the Senior International Director for Europe at Nextracker. And then we have two colleagues, and you will introduce them by yourself, okay?
Yeah, okay. Thank you very much. So the presentation is structured. We are going to talk Antonio Sendin, myself, Antonio Buiza, the technical engineer for TrueCapture, and then we have a special guest that is Michael Vassakis from GRIDSERVE. That is a company that is already, say, installing our tracker on the field. I will be quite fast because you know it's the last presentation. I think people maybe can be tired to be here in the whole morning here. This very interesting session. Okay, regarding Nextracker, as Michael talked, we are the leader in the tracker sector. We have already installed 90 gigawatts of trackers around the world. We are an American company, a Nasdaq listed company. We have more than 500 projects located around the world. We have projects in Sweden. We have projects in Europe, outside of Europe, the USA, also Latam. So we cover all the continent, all the world in the different offices we have around the world. We also have deployed 45 gigawatts of TrueCapture. That is our main topic of this conference. And we have also deployed 9 gigawatts of STR. That is a product that I will explain you a little bit in detail a little bit later. Next slide, please. We have presence in Europe. From the office in Europe, we support customers that are located in Europe. Maybe they can do projects in Europe or outside of Europe. And we support this customer from this office. We have already 5 gigawatts of projects in Europe, in more than, or in the 11 countries, and working in other countries too. Okay, our main office is located in Madrid. We are more than 60 people already in Europe to support customers located here. Next slide, please. I'm going to talk briefly about the product. Nextracker is a 1P, one portrait, so one modeling portrait tracker. Our roles are independent. We are able to reach up to 4 streams with the models. It's a self-powered tracker. It's wireless with wireless communication. Our tag is also self-branded, so it's equipotential, the whole system. And we have deployed now a new product that is already, as I mentioned, we have more than 9 gigawatts of product on the field. That is the Nextracker XTR, right? Maybe you can go to the next slide. Okay, this is the XTR that we are seeing that the areas where the tracker has to be installed, they have been they are quite difficult on orography, so we have to adapt to the terrain, and our tracker is able to adapt to the terrain in this complicated area. So we can decrease the earth movement calculation for this kind of projects. So we decrease the time of installation, also the cost of the BOP of the product of the project. Next slide, please. As you can see here, the Nextracker horizon, we are able to adapt to the terrain. No? The top part of the slide is the Nextracker horizon, is the product that I'm showing you now. That is the product that is adapting to the terrain, and we also have the Nextracker horizon, that is the product that has to be in a flat slope. The whole product, right? The whole string. So with Nextracker XTR, we're able to decrease the number of cubic meters on the field for the tracker. Okay, next slide, please. So just to finalize, and I will give the voice to Antonio Buiza and Michael Vassakis. We have one project, one tracker in portrait, following the terrain that XTR, and the one that is flat, right, on flat terrains. And of course, in our portfolio, we have the TrueCapture. That is the main topic we are going to talk. This TrueCapture is a software increasing our our production, the production of energy of the PV plant. Then I will leave Antonio Buiza to explain in a better way how it works. Thank you.
Thanks, Antonio. Thanks, Michael, and thanks everybody attending after a long morning. In the next 10 minutes or so, I will try to explain what TrueCapture is, a brief overview, because there's a lot to say about it, and also to try to explain how you can get the most out of your Nextracker Horizon or XTR systems using TrueCapture. But first of all, some figures already introduced by Antonio. TrueCapture is right now in operation in over 30 gigawatts of our trackers. This provides a huge user base to understand better how to keep optimizing our system, our software for future deployments. On top of those 30 gigawatts, there are another 15 gigawatts up to 45, which are in benefit evaluation period or are still not commissioned, and I will get into that later. Which means that basically half of our projects worldwide, which are getting close to the 100 gigawatts milestone, count with a TrueCapture installation. Among our customers, some of the top tier IPPs and utilities worldwide from different continents, and something I will touch base a bit later is the bankability of TrueCapture. Supported by top-tier independent advisors and engineering firms. Okay, a bit on how TrueCapture works based on 2 control modes and 2 control algorithms. I think this has been discussed more or less during the morning, so I will not stop a lot. Yes, I will make a special emphasis on the differential values that TrueCapture has. As many other software systems, what TrueCapture tries to do is optimizing the energy yield, the power yield, when diffuser radiance is dominating in your PV plant. How you do that? Well, you try to get the panels or the trackers into a skyward facing position that will maximize not only the global irradiance, but also the reflected one in case you're using bifacial panels. The difference here with other products in the market is that we've just launched to the market the zonal diffuse mode, or how we call it is the cloud tracking system that using not only irradiance sensors, but also the smart modules that we use to power the tracker is capable of literally tracking the clouds passing by the PV site, meaning that you don't need to put your plant into diffuse mode completely if just part of the plant is being affected by cloud shading. And this is recalculated every 2 minutes, so it's really helping a lot to keep the most of the plant tracking normally while part of the plant is in diffuse mode. The other mode is the backtracking or 3D backtracking, as widely known in the market, in the industry. Shade avoid is basically what everybody understands by 3D backtracking, is trying to avoid the shading in complex terrain from one road to another. The difference, or the main difference here that we provide, is that the mapping of the plant is a real digital twin, not based on engineering documentation, on a layout or a topography from an AutoCAD. Is based on a 3D mapping of the PV site when the tracker has been commissioned. So it's extremely accurate, and it helps to reduce the underperformance of misalignment from the engineering to the construction phases. And on top of that, we have a split boost, which is an additional level of optimization on top of the 3D backtracking, specifically for the split cell models, which means that at the very early morning and very end of the day, and this is done automatically by TrueCapture algorithm, the system is capable of evaluating which mode will be producing more energy yield, either shading avoidance or split boost. Split boost means that just the lower half of the module, in the case of a split cell modules, will be covered. But the model will be facing towards the sun instead of being in a nearly flat situation. We will see this in a second. At the end, and this graph has been shown this morning a few times, what we try to do is optimizing production with backtracking, with row-to-row mode at the early morning, at the end of the day, and in case of diffuse mode, of diffuse conditions, also trying to optimize the capture of irradiance by the models. As promised, I think the best way of understanding how Nextracker and TrueCapture work together is seeing it in action. This is a real video where all the modes we have introduced working together. In this case, it's medium afternoon or before the end of the day, some clouds in the sky, and we have the diffuse mode active. Okay, and when the sky gets clear, the clouds lift, it will go to the plus 60 degrees position, and then it will start doing what is called the traditional backtracking, okay, or shade avoidance, until it determines that at some point going to split boost will be more beneficial than keep trying to avoid the shade. As we can see, the system is extremely accurate and will never cover more than the lower half of the model. At the end of the day, when the sun sets, the tracker will go to night stow position. Okay, very quickly, yes. TrueCapture is part of our advanced software license, which includes much more than TrueCapture itself. It includes Navigator, which is our kind of our SCADA, that have also very advanced solutions like hail stowing, flood stowing, flood stowing, snow stowing, and many management tools that are very, very advanced and very interesting for our customers. I don't have time to describe all this, but I will just stop on the Hail Pro stowing mechanism. This is actually Navigator interface, which is capable of bringing the tracker to a hail stow position before hail actually happens, using forecasting systems and determining or setting some threshold like the probability of hail, the distance from the storm, the hailstorm, or the size of the hail. You can anticipate any damage and go to hail stow position before actually happens. As promised, there is more than just the technical features from TrueCapture, and it's a very differential business model that is strongly supported on the bankability of TrueCapture. And this bankability of TrueCapture is provided by independent advisors, like the three that we see in this slide, where we can have reports that can be shared with customers, and where we can see in this case, for example, site C for NRTs, there is a model gain for diffuse, a model gain for row-to-row backtracking, and then the measure gain. The measure gain is done on a controlled environment or controlled scenario on the real plant, as I will explain later. But the important thing is that the modeling can be done by these independent advisors, and the result is that TrueCapture is fully bankable. And that means that using these independent advisors, our customers can actually cover the cost of TrueCapture in the financing of the project. Apart from getting a better financing, because the energy yield of the plant in the 25 years lifespan of the plant will be better. The cost of TrueCapture itself can be included in the financing, and this is how most of the 30 gigawatts we have in operation have been done. This is not something theoretical. This is how actually our customers do it. And something that is also, even if that's not enough, even if the independent advisors support is not enough, we offer also the possibility of evaluating TrueCapture. That means that we will go to your operational plant with Nextracker, Horizon, or XTR. We will install TrueCapture, and in a control environment, defining blocks where we will measure with different slopes, and we will separate the measurement of row-to-row backtracking, diffuse compared with control blocks. We will be able to show you along a year how actually TrueCapture performs. And we are actually capable of shaping the pricing model of TrueCapture to the actual measured benefit of obtained after this 1 year benefit evaluation. And at the end of the year, if you're not happy with TrueCapture, we will just install it, and no charges will apply from that point onwards. There's nothing closer in the market to guaranteeing the performance of this type of software. Okay, and finally, before passing the word to Michael, an example of an ongoing project is not extremely northern latitude, but it has a lot of diffuse irradiance. So we have a plant in Maine, United States, where we have divided the plant into blocks, one a control block, and the other one just to measure the diffuse gain. Okay, we made an estimation that was around that we should obtain just on the diffuse gain around 1.9 benefit, and after 6 months, the measured benefit is close to 2%. So usually, and as you have seen also in the reports from the advisors, we underestimate the gain that we will finally obtain with TrueCapture. And with this, I will pass the word to Michael. I will stop sharing. As already introduced, Michael is the CTO of GRIDSERVE, but he will introduce himself much better. Thank you.
Antonio, give me a second. I'm just going to share my screen. Please check that presentation mode works for everyone.
We are seeing your auxiliary screen, not the main one.
Just flip this.
There we go. That should be correct, is it?
Now, yes. Thank you.
All right, excellent. So, hello everyone, and thank you for inviting me to support the claims that Nextracker has made. My name is Michael Vassakis. I'm the Chief Technology Officer of GRIDSERVE, with the business since 2017 when the business started, and we started off as a developer in EPC, and we went on to thereafter provide operation, maintenance, and asset management on our plants. But we have actually become more than that. We are now a charge point operator, and we are also an asset owner. And because videos are better at describing the full background of our business, I'm gonna very quickly play a video for you all. Unfortunately, sound cannot come through. We've tested that. However, you should be able to read the description and understand what GRIDSERVE is all about. Right. Hopefully you were able to see the video. So just very quick comment here to say that as per the video, also our purpose is to deliver sustainable energy at the speed and scale that is needed to move the needle on climate change. We all know that there is a race against the time. And how we propose to do that is through a sun-to-wheel ecosystem, whereby we generate electricity through obviously primarily solar. We have distribution network, which is our electric vehicle charging infrastructure, and we also support the consumption of this ecosystem by providing services such as car leasing, which people in the UK can get through salary sacrifice as well. So these are the core business verticals of GRIDSERVE. We focus on energy generation, co-location primarily of solar and storage projects, car leasing as just discussed, and of course our charging infrastructure, which is finds application in the UK in the form of electric forecourts as well as electric hubs. In 2019, GRIDSERVE became UK's technology and market leader, and we installed more solar than any other business in the UK, whilst delivering multiple UK firsts and innovation. So we had to do a lot of pioneering in terms to get the solar farm design as we needed it to achieve higher yields, stackable revenue by combining revenues from multiple sources, provide great flexibility so that we can have a project that provides additional support to the grid rather than damage the grid through uncontrolled generation. And of course, deliver a project which people can depend on it, can operate reliably. And we did this, we kind of became technology leaders. We achieved this by having innovation meet deployment and by pioneering numerous technologies, primarily by working with like-minded partners such as Nextracker to deploy a high-performing architecture. Every little yield benefit obviously matters when you're trying to deliver a project in a subsidy-free environment. And we went on, therefore, to optimize the specification of our first York hybrid solar farm, which was UK's first subsidy-free solar farm, combining technologies such as bifacial and single-axis tracking systems for the UK market, in a co-located arrangement with lithium battery storage systems. I'm sure everyone is thinking, well, there's nothing new about this, and you're probably right if you consider this is 2024. However, we take into consideration that the project was conceptualized in 2017 and delivered in 2019. You will then realize that half-cut modules were not even at the market at the time of the design. The single-axis tracking systems were never proved at latitudes greater than maybe 40, 50 degrees. Probably Antonio can testify to that. Energy storage co-location of projects is not something that we were seeing in utility scale. And therefore, we brought expertise from market leaders to include, obviously, Nextracker, to help us in this mission of delivering UK's most advanced solar farm. And that's what York is known as. It was effectively a success case, which we went on to deliver with all of our partners, key suppliers, whereby TrueCapture played a role to the success, increased yield output of the project and the performance of the operation. So what did we do after the project was actually delivered? We evaluated the benefit of TrueCapture by selecting 2 blocks with different slope angles to establish exactly what is the gained benefit when we test against row-to-row shading, or and also taking into consideration the split boost mode. So we selected 2 blocks, block number 4 and block number 7 out of the project, And we went on to analyze the performance in order to establish whether what we were estimating was actually something which is in fact tangible and can be measured. And in fact, in line with the what we expected, we did manage to measure the benefit of these projects. For Block 7, we measured gains of 0.95%, whereas for Block 4 we had a 0.82% measured gain. We can see that against what was originally estimated of 0.47%. 0.74%. We did establish that in fact the actual gain of the project was higher. So we can fairly say that Nextracker took a conservative approach in terms of simulating and modeling the performance. Here you can see 2 consecutive days with TrueCapture on and off. The first day, we're now looking at Block 7. The first day, you can see the multiple different angles of the trackers. We can observe the trackers in operation, whereby the algorithm optimizes the tilt of each one separately to achieve higher overall performance. And then the second day, the trackers are all following the same tilt throughout the day, and therefore you can see that they all have the same angle. Looking at the block number 4, equally, we could see that the algorithm there provided a similar reaction as to Block 7. Both of the blocks outperformed the expectation, but also in conjunction to the control blocks, we could establish the higher power output. So this is the project. This is York. This was the first of its type, delivered in 2019. The first project that was established as a subsidy-free solar farm. And technologies such as TrueCapture really supported in delivering the project by making it financially viable at a time where there were no projects being built in the UK market. So as discussed, first project to feature bifacial modules, first project to take leverage on the synergies of single-axis tracking and bifacial half-cut modules with advanced algorithms developed by Nextracker. First project to have a shared co-located grid connection of solar and storage. And the first one, in fact, to be Type-C under EREC G99, which whoever is familiar with the UK market can be quite onerous. And it was actually, in fact, a success case. And therefore, that's a testament to the fact that we thereafter went on to deliver whole hybrid solar farm. And a recipe that works does not need to change. And therefore, using the same supplier, same technology, we delivered almost an identical twin in terms of specification for whole. And we didn't stop there, because we thereafter went to improve upon our existing architecture. Again, with Nextracker on our side, we went on to deliver Sarcester. This was the first large-scale DC-coupled solar farm in the UK, and one which challenges the status quo, whereas the AC-DC ratio is completely different to what anyone might be familiar with. It's more than 200%. We had presentations today whereby we could see AC DC ratios of 118%. So people can put things into perspective. And how did we make this possible? We made this possible with long duration energy storage. So we went on to deliver this project, combining again and improving on existing innovation, on existing technology, pioneering new technologies and pushing the boundaries. Again, this is how we delivered these projects with Nextracker. These are the projects that provide the net zero energy that GRIDSERVE is using on our electric vehicle charging infrastructure. And we're still on a mission, and whether people want to talk to us, reach out to us, whether it's for electrifying their EV fleets and salary sacrifices, or whether it's in regards to our experience in providing EPC services, operation maintenance, asset management. Please feel free to reach out to us, because the intention from our side is to make a change and have a positive impact towards moving the needle on climate change. So again, I think we're all here in this forum like-minded people, so happy to pick things up separately on a one-to-one. Equally, if you have questions now and we have time for questions, we can equally do that.
Yeah, cool. Thanks. So I think let's take very interesting. So I think let's take simply time for 2 questions. So first to Michael, maybe you. So what needs to happen actually that trackers become a standard product for you in utility scale applications?
I think it's fair to say we kind of pioneered trackers as a technology. The industry is going to be moving forward with innovation in all sorts of areas. I think one of the things that we're going to be experiencing the following years is going to be a lot of innovation in the solar modules, whereby the price of the modules is actually is very likely to go up. So when we see multi-junction modules hitting the market, whereby we're going to be able to have higher efficiencies and the price of the module is also going to be higher, it's going to make a lot more sense for trackers to be deployed, because at that moment you have a fairly expensive PV module which you're putting under best conditions by tracking and using algorithms such as TrueCapture to yield the most that you can out of the modules. So inevitably, that increased efficiency of power modules is going to aid into adoption of trackers in greater volume. I think in addition to that, the reliability and having a track record of reliability of trackers is something which is very important. Having a tracker supplier who can dependably support the project and thereafter ensure that the yields evaluated during the financial and the business case of the projects do actually get delivered is equally important. And we've seen reliability increase the past years substantially. Trackers are not a new technology; they're a well understood technology now, and therefore more and more people are going to feel more comfortable with deploying these in mass rollout. So your question is as to whether we have actually reached the tipping point, and I think we've exceeded the tipping point whereby trackers make sense as a financial choice. But the market adoption needs to still reflect that statement, and there is the track record from a lot of successful projects. Your car project is just one of them, whereby we can substantiate the claim of higher yields by looking at the results. The projects that we have delivered have all overperformed against their simulated analysis and original kind of PV assessments and so on.
Okay, cool. Thanks, Michael. And then maybe quickly to Antonio and Antonio. So, so I think Nextracker is the market leader, and you're, if we look at Spain, there's a lot of tracker products, but this is about the northern latitudes. So I think if you, I live in Germany actually, and here it's pretty much a desert in terms of tracking projects, although there's quite some utility scale. So how do you really want to crack that market now, actually? So because of course, as Michael said, it is attractive and it increases yield, and there's a lot of reasons why it makes sense. So what's the strategy now to crack the northern latitudes?
So thanks for the question, Michael. So we have already a quite number of projects located in North Latitude. We already have projects located in Denmark. We are now installing our first project in Sweden. So yes, tracker is possible in North Latitude. As Michael told, the GRIDSERVE project in the UK were the project in higher latitude ever in Nextracker in 2019, right? And we thought, okay, this is something. It's very strange, no? Somebody is going to install trackers in so North Latitude, but yes, they did it, and they are overperforming, and the financial model is working, right, Michael? So, and even he told us that the yield of the production energy of the model was even before that the real energy production they are having. So tracker is a competitive and let's say competitive and you will gain more money installing trackers in your system in your PV in the PV panel, and including also the TrueCapture, that is a software increasing the production in in cloudy days, or using the XTR, that is the tracker that is adapting to the terrain, so we can implement our tracking in more difficult orographies, more difficult terrains. So yes, we are cracking the market with the tracker. We are also focusing are now working in Latvia, for instance, on other projects. So I think the tracker is the solution for Northern Latitude. Yeah.
Antonio, can I add to that to that comment if Michael allows?
Sure.
All right, excellent, Michael. I'm just not sure how much time we have. So one of the key benefits by using trackers is how the generation curves change throughout the day. So we're actually impacting the generation profile throughout the day by generating a little bit earlier in the morning, delivering a little bit more yield at the afternoon, and that has an important role when it comes to advanced markets such as Germany, the UK, and other European markets, because when you actually get to combine trackers, energy storage, as well as the technologies that we have pioneered in the past, you are able of providing a more stable power output of the solar farm, utilizing that connection for longer and smoothing out your power output, making it even flatter, if you like. So therefore, providing more flexibility for the asset, and trackers actually aid to that regard by just changing and the profile and removing the solar peaks as we've known them. I had a slide within here which I actually removed that demonstrates this very nicely, but I think we all know what the generation profile of a tracker looks like against a traditional solar farm. And markets such as Germany, which have a lot of traditional solar deployments, see that peak cannibalize the energy of the energy generation price, and therefore, if you can distinguish yourself from any typical solar farm by not having a truly south-facing project, then you can expect that throughout the lifetime of the system, and these are 25-year-old systems or above that we're delivering, you're going to be able to capitalize by not generating when everyone else is as well. So also having energy storage means that splitting the generation curve or extending the generation curve, having a flatter power output from the trackers means that you have to size your battery differently, because you don't necessarily need to capture a peak at a specific time. Instead, you can have your financial analysis and generation modeling optimize your battery size by not going so high in terms of the size of the battery. So there are a lot of things that someone needs to take into consideration when we deliver the projects of 2024 and onwards. The answer might not be, just when we're looking at the solar benefit alone or the yield benefit, but rather how does that tie in with the market requirements of European markets or elsewhere.
Yeah, I fully agree. And I think this is also probably then a question of framework conditions. So how ancillary services and so on is actually, or flexibility is actually also remunerated, right? Cool. Thanks so much for this great presentation. And yeah, I think that's it.